So I'll be going over my physics portfolio. More specifically, I'll be going over the places where I thought I grew the most, the least, and I'll be telling you guys a general takeaway I can take from this class. So first, one of the places I thought I grew the most in was models and representations. So this is because in my first model at the beginning of the year, it's very simple. There's not much information that can be obtained from it, and it's of a relatively simple type of problem, just an Atwood's machine. And then just right now, at the very end of the year, I've got a diagram of my roller coaster, and in this diagram, it has calculations set up with each part of the roller coaster, so it guides the reader. It also has the type of unit that will be used in that certain part of the roller coaster, and also it has every single distance labeled, which is needed. A second practice which I thought I grew in the most was using mathematics. And so this first example is taken from one of my very first labs in either August or September. And it's of a very simple concept, just dividing force by normal force to get the coefficient of friction. And so in this, I was able to screw up this very simple concept and used wrong units, and then so I ended up getting extremely small numbers. And because of it was such a simple concept, and because I couldn't even solve it, I believe that was one of my worst things I've done. And then the second picture is of a very difficult concept in physics of momentum, solving for two unknowns, and it requires that the student has an understanding of quadratics and be able to logically determine the answer from the two answers given. And so overall, I believe this is a huge difference from the very beginning of the year, and it demonstrates my understanding of complicated mathematics and advanced physics. Okay, so now in the place I believe I grew the least. I believe I grew the least in scales and representations. This is actually what I thought I grew the least in last semester as well. This is because it's quite obscure. It's kind of a vague definition, connecting different physics between like space and time, or time and other units. And so I believe I wasn't really able to grasp this concept. But what I was able to do was to directly connect things we're learning in physics to things we do in the real world very frequently. And so I used cars and momentum and impulse, and then I used circuits and light bulbs, both which are very common.